Today, I'm going to talk not just about microservices, but I'm going to tell the story of how we actually came to start thinking of microservices as service-oriented development. And I'm going to talk about why we think this is one of the most effective perspectives to approach microservices from. And I'm also going to cover how to start building your own platform for doing service-oriented development in an incremental way. But first, a quick poll. So, show of hands, how many of you have asked these sorts of questions about microservices? Things like, how do I break up my monolith? How do I architect my app with microservices? And what kind of infrastructure do I need in place before I can benefit from microservices? All right, a good number. So these were the exact same questions we had when we started out. And we kind of learned the hard way that these really aren't the right questions to ask to start with. So what is the right question? I'm going to get to that, but first I'm going to start with a little bit of our early history and some of the painful lessons that helped us figure out what the right question is, because I think this will give you guys the context to appreciate what I'm going to talk about. So we were founded in 2013. And my co-founder and I, we were, both tool builders by nature. So we wanted to help people build things. People were building distributed systems. I had a strong distributed systems background, and microservices was the way people were building things. And so it pretty naturally turned into a company that wanted to help people with microservices. Of course, we had a lot to learn at the start. And so we dove in, and we started out primarily with a sort of a technology-first perspective. And we tried to learn by speaking to all the big guys that were doing microservices. So we talked to folks at Netflix, Twitter, Yelp, Google, Facebook, and a bunch of other companies. We talked to engineers on the platform teams. And we pretty much tried to reverse engineer their technology stack and how they were using it. And pretty much this picture of an emergent architecture for microservices emerged, right? This control plane and smart endpoints. And the control plane was sort of always the same set of backbone services, things like discovery, logging, tracing, and metrics. And the smart endpoints were all about providing resilience, all the resilience semantics you need for layer 7 network stability, things like timeouts, rate limiting, and circuit breakers, and a whole bunch more. So we took a look at this and we said, all right, that's a lot of tech to build just to get started with microservices. So we can help people by building this all for them. And so that's what we did. We set out to build a control plane as a service. We used microservices ourselves because it seemed like a pretty natural fit. The control plane was already split up into a suite of separate services. And so, why not? So, and things went great at first, right? It was pretty fast to start out with, and then we launched and things started slowing down. So we took a step back and scratched our head for a little bit and tried to figure out why were things starting to move too slow. And it's, as is always the case with this sort of thing, when you're in the middle of things, it's not necessarily super obvious. There's a lot of possible reasons you think of. And so we took a look at a couple of different things, right? We took a look at the technology we were using. I think we went through, maybe 5 or 6 different deployment systems. We took a look at our architecture and we said, okay, maybe we didn't decompose this control plane into the right set of services. So, we tried a couple of things there, rejiggered that a bit, and that neither of those things seem to make that much difference. And so finally, after going through a bunch of releases and sort of looking back and carefully asking the right questions, we figured out what was slowing us down. It turned out that every feature we released required carefully coordinating the efforts of multiple different people. And some of this, these people weren't sort of naturally inclined to communicate on their own. And so some of this was for bad reasons, and we fixed those, and that actually made the biggest improvement in our velocity. But some of this was actually for very good reasons, right? We didn't want to break our users, and so we were releasing things. The process we had for releasing things was deliberately more careful. So in the end, it wasn't our technology or our architecture that was slowing us down. It was our process. Now, at the same time, something else was going slow. And that was something that was actually a lot more concerning, our pipeline. It was a big pipeline. We were talking to about 30 or 40 different companies, and they really liked us a lot. They kept, they were all going through migrating to microservices at one stage or another. And they kept coming back to talk to us because we had a lot of useful information for them. But a lot of them were moving slow, and because we talked to them frequently enough, we were able to kind of track their progress and start to put together a picture of what was happening. And we started to notice a pattern. It seemed like the slow movers fell into two camps. There were a bunch of companies who were being very, very careful and deliberate about baking off all the different technology alternatives. It seemed that they thought the benefit of microservices sort of somehow came from picking exactly the right technology stack. And then there was this other category of companies that were approaching it from a much more architectural perspective. And they were trying to figure out exactly the right set of services to decompose their monolith into. And this meant they were taking a while. And then we also talked to all the fast movers, and we finally had a brilliant idea to ask them to tell us their story. Tell us about your first service. Tell us how you actually did this. And with the fast movers, we got a whole host of different answers. We talked to one company that had a Rails monolith, and they had some kind of file upload functionality, and occasionally some user would upload a multi-gigabyte file, it would take down the monolith, and the whole application would go down. And so they had to fix this pretty urgently. They decided it would take too long to fix within the context of their monolith, and a file upload endpoint is a really simple service to write. So they just wrote it outside the monolith and were able to deliver it really quickly. There was another company that wanted to adopt modern CI/CD tooling, and they decided that it would take way, way, way too long to retrofit their monolith, and they just decided to start implementing new functionality outside their monolith and adopt the new tooling as they went. And there was another company that had a bunch of personal private information, and they wanted to minimize the scope of the audit process that's required for code that has access to that sort of thing. And so they isolated and contained those in services that were as small as possible. And so the common theme seemed to be that all of these companies had an urgent need that could not be addressed quickly enough in the context of their existing process. And so we kind of put two and two together with our own experiences and decided that, okay, velocity actually comes from process, not architecture. And this kind of makes sense if you sort of take a step back and think about it, right? We're all familiar with the classic Death Star architecture diagrams of thousands of services that come out of successful microservice companies. And if you think about it, you don't stand in front of a whiteboard and design that kind of Death Star. That's not how you get there. You get there by enabling a different way of working that as a byproduct makes it way faster and easier to churn out the hundreds of services you need to get to that point. And this is when we ditched the whole idea of service-oriented architecture, fine-grained or otherwise, and started thinking about service-oriented development. And to understand this, it really helps to recognize two things that dramatically impact the way we work. So first of all, in software, stability versus velocity is a fundamental trade-off. The faster you go, the more things break. And this is why things slowed down for us after we launched. When we were prototyping, we could break whatever we wanted, whenever we wanted. And the second we had users, we adopted a whole bunch of practices which slowed us down, and for good reason. And if you have a lot of users that rely on you, or even just a few that rely on you for something really, really important, the more careful you need to be, and the slower you can move. And what that means is that if you're trying to quickly add features while maintaining stability, there is no Goldilocks point on this curve for you. a single process is inefficient because it forces a single stability versus velocity trade-off. And there's another important factor to recognize. The development process involves a bunch of distinct activities that I'm sure you're all familiar with. And something that can be harder to notice when you're small is that you can really only do one of the activities in this process at a time. Yet when organizations try to scale, they seem to do this by building specialized teams associated with some or all of these activities. And as an organization like this grows, this turns into some combination of dramatic underutilization and departments fighting each other, right? If velocity is your top priority, then operations will get frustrated with developers for breaking things all the time. And if stability is a priority, then operations will ultimately end up putting processes in place that slow down development. And when development slows, product management gets frustrated. And if your leadership doesn't understand this, then they can end up setting up a combination of goals and an org structure that literally pits an organization against itself. And what this means is a single process does not scale with your organization. And this is why instead of asking how to break up a monolith, we like to ask, how do I break up my process? And this is the question to ask if you want to go faster. And this is the perspective to approach microservices from, because microservices lets you have as many different processes as you like. With microservices, you can set up a distributed development workflow, and that lets you customize the processes that each service uses. And when you do this, that's how you can move fast and keep things stable and get benefits almost immediately. Multiple simultaneous workflows, including your existing monolith, all tuned for that ideal stability versus velocity trade-off. So this sounds great, right? So how do you actually get started? Well, starting from the right principles makes this a lot easier. But it's still a huge shift in how people operate. And this requires both organizational and technical changes. And so I'm going to cover some of the ways you can make this easier on both fronts. Starting first with the organizational side of things. First of all, you've got to give in order to get on this front. You need a big emphasis on education, communication, and delegation. If you look at the picture on the right, you can see why. On each of our small teams, all of our former specialists are exposed to every aspect of the development cycle. And so there's a big learning curve. And also, because they're all specialists, nobody speaks the same language, so communication can be a challenge. And with this model, you end up delegating much bigger parts of your business to much smaller teams. And this is sort of the point, but it can also be very scary. But when you do this right, you actually get a lot. With education, your specialists become generalists, and this leads to better holistic systems. With learning comes personal growth and job satisfaction. And with communication, that conflict that was there before between departments fighting each other, that turns into collaboration. And with delegation, you can achieve massive organizational scale. And the benefits when this is done well, they're hard to overstate. I once spoke to an engineer at an e-commerce company, and he told me some remarkable things about the impact of the latency of recommendations on customer conversion. E-commerce sites live and die by their conversion rates, and common wisdom is that product recommendations increase conversions. But this guy knew that if your recommendations increase the page latency beyond a certain threshold, then the human at the other end gets frustrated and your conversion rate drops off. And if you think about this, it really demonstrates a remarkable breadth of knowledge across many aspects of both the business and the technology behind it. So what's the best way to go about doing this? Well, we want to start by creating self-sufficient autonomous software teams. And why self-sufficiency and autonomy? If you have to work directly with other teams to get stuff done, their process is interjected into yours. And if you have autonomy, you can choose the best process to meet your goals. So to get there, there's two things to be aware of. First, you need to be aware of centralized specialist functions and try to eliminate these. No centralized architecture team and no centralized operations team. And don't get confused between a platform team that provides a platform as a service and a centralized ops team that's responsible for keeping all the services running. These are two very, very different things, even though on an org chart they can look very similar. The second thing is to think of your teams like their own little spin-off companies. You probably already consume external services, things like Stripe and Twilio. Well, your new microservices team, think of them just like another one of these. And pick a real urgent business problem that you wish you could buy instead of build, and then form an internal spin-off to build it. This sets up the right mindset for a lot of things. It helps you think from a process perspective. It helps you define the service because you're thinking mission statement. You know, who is the user and what are you trying to help them do? And this is a way more effective way of defining services than big upfront design. And it helps with communication because you're establishing a customer versus a coworker relationship. And it helps you form the right team because with a spin-off, you need a mix of skills. You can't just put a bunch of developers on a team alone and expect them to succeed. You need people with more product-oriented skills who can understand the user, figure out how to help them, and translate that into actionable engineering tasks. And you need people who can code, and you need people who can keep the service running. And you can even do all this with no fancy tooling or technology at all. But it's a lot easier and more efficient if you give them an awesome suite of service-oriented development tools. And that brings us to the technical implementation. So while it's really a spectrum of stability versus velocity trade-offs, I'm going to break this up into three different stages. Early on is what I call the prototyping stage, and in this stage, the goal of your tooling is to give you really fast feedback from both prospective users and the tools we all rely on, things like compilers. Stage two is really about balancing production concerns, users and growth. And the goal of this stage is adding features without disrupting users. And then there's a third stage, and that's the mission critical stage, where the primary goal is stability. We've all worked on stuff in all of these stages. There's sets of tools that you can use to do all of this stuff. So this should be pretty easy, right? For rapid prototyping, we can just build something in Rails on our laptop. For a growing user base, we can just stick it in Heroku. And for mission critical stuff, we'll probably just eventually rewrite it in Go and move it over to a real cloud. So what's the problem with this? Well, we're replatforming at every single step, and that's a whole lot of work. So what we actually need is one platform that can support parallel development at different stages with seamless transitions between stages. And this is a whole lot harder. The good news is that Kubernetes, Docker, and Envoy give you the foundational technology to do a lot of this stuff. And just in case not everyone's a Kubernetes expert, and in case people haven't heard of Envoy, I'm going to cover a little bit about them. So Kubernetes, you can think of it as infrastructure as declarative configuration. And it's kind of like a thermostat. You tell it the desired state of your infrastructure, it measures the actual state of the world, and it tries its best to make you happy. And it provides a powerful apply primitive to update the desired state of your infrastructure to something new. And when you do this, it will safely transition from its current state to that new state. And it's fast at doing all this. And this combination is powerful. It lets me treat my infrastructure like source code. I can check it into Git, diff it, patch it, and this really fits the way I already work in a lot of ways. Envoy, you can think of it as a powerful L7 network proxy. It's L4, L7, but we really care about it for the L7 capabilities. And it provides a huge toolkit of L7 routing and resilience behaviors, along with great observability and things like dynamic reconfigurability and zero connection loss hot restart. And there's a good reason to pay attention to both of these because lots of really smart people collaborate on these to solve some really hard problems. The bad news is that you actually need to wire all these together into your dev tooling the right way in order to get any benefit. And this can be hard. These technologies are all super general, and they solve all of the hard problems you're going to run into, and a whole lot more that you aren't. And they're definitely worth learning, but learning them all up front and then playing around with all the different options for wiring them together, that can actually take a while. So the rest of what I'm going to talk about is really the key strategies that can help you get started with this incrementally. And you might see a shameless plug here and there where we have a tool that might fit into this picture, but I'll try to keep that to a minimum. So how do I actually use these technologies to build tooling for my workflows? Well, if you remember, we want fast feedback from our tools as well as our users. And to reach users, we need to run on production infrastructure. And operations doesn't always like letting developers mess with production. So you need to get buy-in from all parties for an acceptable way to do this. Second, microservices very quickly grow too many remote dependencies to run locally. And not being able to run code locally really slows down the feedback from all the tools you're used to depending on. So, excuse me, we have two strategies for dealing with this. One is you need to build some kind of self-service provisioning, and two is development containers. So the combination of declarative infrastructure from Kubernetes and the dynamically reconfigurable edge proxy, or Envoy deployed as a dynamically reconfigurable edge proxy, is a really powerful basis for self-service provisioning. And when you wire these things together to provide that, you really need to focus on how quickly you can spin up a service from scratch. You might not think that that's a common case, but if you have too much friction here, you might get lazy and end up building what should be an independent new feature into an existing service. And this leads to accidentally coupling the process for your new feature into an existing process. And with Kubernetes and Envoy, you can, with the aid of some relatively straightforward tooling on top, spin up and publish a new stateless service in less than a minute if you can code fast enough. So this helps a lot because you can easily play around with some ideas. You can mock up an API. You can call into other services. You can use your mocked up API in order to figure out if it's actually worth taking it to the next level. And this gets to our second problem. Coding on remote infrastructure is really slow, right? And just for some perspective, a VM-based pipeline has a deploy time, measured in large fractions of an hour. A Docker-based pipeline has a deploy time that's maybe a few minutes. By contrast, hacking React on my laptop with live reload, it's maybe 1 to 2 seconds. And most of this is because somehow JavaScript managed to turn itself into a compiled language when nobody was looking. Hacking Flask on my laptop with live reload is pretty much instantaneous. So how can we do better than this? Well, developing inside a container actually helps with this, and it helps in 2 ways, right? If you put your build inside the container, you now have a single source of truth for your service's build toolchain and all of its dependencies. And this makes your dev environment completely consistent and portable to other developers. And this makes onboarding easier, or having devs jump between services easier. And this also helps you build a faster feedback loop. And there's a bunch, because as soon as you do this, there's a bunch of strategies available to you, right? You can run your dev container on remote infrastructure and sync your edits locally, or sync your local edits and rebuild and run your code right there. You can run your dev container locally, sync files, incrementally rebuild, and snapshot the live container to create an image in seconds. And when you do this, this even works for compiled languages that take a really long time to build from scratch. And using this technique, you can deploy just about anything in seconds. You can also, with a bit fancier tooling, use a two-way proxy to wire that live container that's running locally directly into a remote cluster. And this lets you do all the live reload stuff or step through your code in a debugger. And this can happen while your code receives traffic from any remote services and sends traffic to all of the remote services that it depends on. And option 2 and 3 can actually work pretty nicely together. Option 3 lets you use all of your local tooling while you're in the zone, kind of hacking away. And then when you're happy, you can use option 2 to quickly push your changes into a shared deployment so other devs can see them. We actually implement both options 2 and 3 in our awesome free and open source tooling. So if you like the sound of any of this stuff, you should go check it out. And if you hate the sound of any of this stuff, you should definitely go play with it in depth just to make sure it's as awful as you really think it is. Now, I know all this fast deploy stuff is really motivated by prototyping workflow, but it actually goes beyond that. Being able to quickly fix things when they're broken is actually the most fundamental resilience strategy of all. And I think it often gets underused. I have theory that this is a holdover from that org level dev versus ops tension. The only way typically that developers have to keep things from breaking is to try and anticipate and then eliminate bugs up front. And the only way operations has to keep things running is to restart or roll back to a known good version. And this is actually really limiting because developers don't think about strategies to test things in production, and increasing numbers of things these days can only really be tested in production. And operations doesn't tend to think about fixing things quickly by rolling forwards instead of rolling backwards. And that's a shame because in modern systems, things often break because of unanticipated environmental changes, and rolling back doesn't really help with those. And this brings us to stage 2, trying to add features without disrupting users. And so the key organizational challenge here is recognizing the reality of that stability versus velocity trade-off and making a deliberate choice for each service. Measuring user impact is actually a business level problem, and you need to consider this as well. It's not just about 500 errors. To go back to our e-commerce example again, if conversion rate is fundamental to your business, you need to measure that and make it available to your developers because, as we now know, backend latency can impact that a lot in unintuitive ways. So the key technical challenge here is that you're changing code in production. And you've got lots of protection from hardware failure these days, but how do you protect yourself from your own bugs, right? If you roll out the exact same buggy code on all umpteen nodes of an HA cluster, you're going to end up with some catastrophic failures. And more, as we said before, more upfront testing does not help. We need to emphasize, or we need to minimize the impact of unanticipated bugs. And the basic strategy here is genetic diversity. We want to keep multiple versions deployed so that any single bug is less likely to be catastrophic. The most basic form of this is canary testing, but you don't need to stop there. You can keep as many versions around as you like and slowly retire old versions as new versions get hardened. And again, Kubernetes and Envoy can do a lot of the heavy lifting here for you because Kubernetes lets you keep your infrastructure declaratively described in Git. The mechanics of deploying as many different versions as you like are pretty straightforward. We do this by mapping Git branches directly to deployments. Instead of keeping the manifests in Git directly, we keep a templated version of our manifests, and we can instantiate that as many times as we like using a variety of different profiles that get determined from the current branch. And this means you can roll your service back, roll it forward. You can run multiple parallel versions, all in terms of whatever Git workflow you want to adopt. So this one diagram you're looking at, it can become both an infrastructure diagram and a Git branching diagram if you like. And this makes transitioning between workflows super seamless. You can just deploy straight to a single primary version from your command line while you're early, just like you commit to master if you're just playing around with stuff. And later on, when you want to emphasize stability, you can just run the exact same deploy command off a PR or tag in your CI/CD server for a much more regimented workflow. Now, you do need a little bit of integration so that you can trigger Envoy routing reconfiguration when these things spin up or down. And we do this in another one of our free and open source projects, self-service API gateway called Ambassador. And it provides that little bit of integration that dynamically reconfigures Envoy based on annotations in your Kubernetes manifests. And just like fast deploy helps with resilience, this multi-version deployment actually really helps with prototyping, because with this same basic model, every developer can deploy their own private version to hack on for any service. And you can even configure Envoy to give them a special host prefix, or a host or URL prefix that they can use to access it, just like they would access the primary version. And that speeds you up even more. And before you know it, you'll be ready to start worrying about stage 3 services. So I'm going to try and keep this short, because this stuff is definitely not part of getting started with microservices. But I'm happy to answer more questions about this later on. What I will say here is that focusing on the organizational fundamentals will probably help you more than technology here. And that's because there's actually a bit of a failure mode here where organizations can regress back to a centralized process when they get to this stage. This usually happens because at some point you have a cascade failure. It's a big deal, and someone gets put in charge of making sure it doesn't happen again. And depending on what they decide to do, they can end up effectively reintroducing a single centralized process. Now, the basic strategy for dealing with this is to define explicit service level objectives, things like per consumer throughput, latency, and availability ranges, and provide good layer 7 observability. To understand how these things work together, it helps to understand the nature of cascade failures. They come up when you have long chains of synchronous dependencies, and you can think of them kind of like Christmas tree lights. When one service goes down, the whole chain can go down. And so to prevent this, you either need to consider service D mission critical, thereby slowing it down to a crawl, or you need to change the nature of the dependency that C has on D. And there's a lot of different ways to do this. You can make it asynchronous, you can cache it, or denormalize it, or eliminate it entirely. So how do you decide what to do when something like this becomes a problem? Well, first, you need good network level visibility so you can actually root cause something like this. And second, if service D has clearly defined service level objectives as part of its contract, and D's outage causes C to violate its service level objectives, which won't necessarily be the case. If it's a prototype, you might not care about its uptime. Then it's clear whether Team C should take action to change the nature of its dependency, or whether Team D is actually violating its contracts and should take action to improve its stability. And this can happen without draconian levels of centralized oversight. And this is one of the things that I find really, really interesting about microservices. I came to this early on as a purely technical problem, but now I view it as something that's actually a whole lot more than that. And for me, learning about microservices has really been about learning how people can work together better. And the part I like best is that it has this almost paradoxical element where enabling people to be more self-sufficient actually turns out to be key to making them cooperate better. And I really like that, because despite the fact that I've been on both sides of just about every argument a group of crotchety engineers can blunder into, I think the only reason it really works is that deep down people really want to cooperate with each other. And when you figure out how to actually unleash that, the results can be really phenomenal. So start with thinking about how to break up your monolithic process, spin off self-sufficient teams to give your people the freedom to figure out how best to help each other, and support all of this by building awesome tooling for service-oriented development. Thank you. If you're interested in reading more about any of this stuff, you can check out, we have some hands-on tutorials on our website, and you can check out the tools that fill in just a small part of what you need for a service-oriented development platform up there. I'm happy to answer any questions.
Hi. You made a distinction between an ops team and a platform team. Would you elaborate on that a little bit, please?
Yes. So, this is something I've seen happen as companies that thought they were doing microservices and they thought they were doing microservices at scale actually go through. And so the ops team is really the ones that are on the front line and is responsible for keeping each service running. And if you have thousands of services, you can't centralize that ops team. The platform team is really just responsible for providing what you can think of as almost a domain-specific platform as a service to enable the rest of the organization to function, right? And so, platform team is, effectively the team that would be building the tooling to support the rest of the team. But it's really more of the relationship between the platform team and the service teams is really more of a customer relationship. I think Netflix is actually famous for actually explicitly formalizing that. So if there's any tooling, they produce a lot of internal tooling, but every team is free to choose whether or not they want to use that tooling, build their own, or use something else. So hopefully that makes it clear.
Hi, right here.
Yeah.
So you mentioned, so you'll be glad to learn that in our company, we do almost all of these steps. We have all of this, it goes really well. However, one of the bottlenecks we face is deploying to production. That pipeline that takes what you have developed internally across the company,
Yep.
By the time it makes it to production, that entire process could be really slow. It's not like it'll go out in 2 days because there are a lot of things we need to provision for, the redundancies, what are the data store requirements, SLAs, and so on and so forth.
Yep.
So now if you break all these teams up into autonomous teams, this entire end-to-end is really hard to deliver because of that particular common requirement across all the teams of deploying to production. So, question, what challenges have you faced with respect to that? Have you experienced it to be a bottleneck ever? And how have you solved this problem? Or what are your suggestions to handle speedier deployment to production and not make these things a bottleneck?
Yeah, so that's definitely a factor. I think that's why you see sort of the first generation or earlier microservices companies have much larger platform teams because they had to build a lot of that stuff for the rest of the teams to depend on. These days, there's been multiple generations of sort of microservices companies, and the way I look at microservices, the way I look at high growth SaaS companies is they're machines that VCs dump loads of money into in one end, and they spit out microservices platform technologies, open source microservices platform technologies out of the other end, because they all have lots of money, lots of people to throw at these problems, and they build lots of tooling to help them. But more recently, there's really been convergence around some of these tooling. So there's a lot, sort of, the choices are more obvious, and it's easier to assemble this stuff. So Kubernetes, like I said, it's doing most of the heavy lifting around that deployment. And using Kubernetes, you can spin up, you can make that deploy process as fast as you want, right? So the limiting factor with the right combination of Kubernetes and Docker or Kubernetes containers and some kind of dynamically reconfigured API gateway, the limitation really just comes down to the process you want to choose, as opposed to the limitations of the technology.
I have maybe more a comment than a question. I think that you seem to make the statement that there's a trade-off between velocity and stability.
Yep.
I think that's wrong. I think it's really a sort of like maybe a triangle or a three-dimensional space where complexity or simplicity comes in. I was back at Amazon a little over 10 years ago. We launched a service in like 3 days that was called an every page load, but it was super, super simple. And I think one of the tricks of like getting the architecture right is coming up with those like simple services.
Yeah, so that's an interesting question, because people ask me a lot, how do you design a good microservice, right? And I never used to know what to say because like I have no familiarity with the domain of whatever company they're from. And so I'm really not in a position to answer that question. But I did eventually come up with a good answer, or a clever answer at least. And my answer is the way you design a good microservice interface is by throwing away a whole lot of bad ones first. And that's where, that's part of the difference between sort of the service-oriented architecture idea and the service-oriented development idea, right? It's the difference between the slow, deliberate architecture process of trying to predict in advance and the sort of faster, more iterative process of, okay, we're just going to try a bunch of services. This is the problem we're trying to solve, and we'll try a bunch of different APIs and see what sticks, right? And one of the things that has been shifting at a really rapid pace that the cloud has enabled, and now a lot of the newer technologies for using the cloud has enabled, is that you can actually apply that much more rapid iteration process to distributed systems. And that didn't used to be the case, right? It used to be the case that distributed systems were really, really slow and expensive to set up. And now they're cheap. You can just try stuff, and if it doesn't work, throw it away. And so if you look at the last example, right? If you think of architecture as really being the topology of your services, right? If you look at that last example with the Christmas tree lights, you have architecture happening, right? The shape of your services is being defined, but not in a centralized way. And that's how you get architectures that are too complex to fit in one person's head, right? You're doing it by moving sort of the boundaries between your services. You're moving that choice of how to structure the boundaries between your services from a technical decision to just a much higher level decision, right? The job of this service is to help this user accomplish this thing, and the team can try as many different APIs and have as many different parallel APIs as necessary to accomplish that goal. All right, and that's why I think search is a great example, because it's one of the most intuitive, easiest microservices. And when you're trying to work in a service-oriented development style, a lot of the natural architectural intuition that you might have, it kind of gets in the way. So you don't think to just try things. You think about your instincts and whatnot that are probably based on data that's maybe 5 years out of date. And so that's something you kind of need to constantly fight against with this sort of thing. So I don't know if that answers your question, but I mean that's one of the ways that this kind of tooling that just speeds this stuff up. It can actually help you with design because you can just try so many more of them.
I have a question. So you were talking about spinning off the teams.
Yep.
As these small teams.
Yep.
So can you talk about, like, I think one of the things that makes it easy to have a monolith is that it's easy to attribute cache, right? So cache flow to a particular monolith.
Yeah.
Can you talk about how to create that feedback loop when you have these small teams, like which teams are actually being effective, and can you spin up multiple of these small teams providing a similar service like you would see in a marketplace?
That's an interesting question. When you're talking about cache, are you talking about revenue or cost? Both. So it's something. Because we're trying to help people get started with microservices, we tend to sort of focus on the smaller to medium scale issues. But that is something that definitely comes up when you're at a larger scale. And there's great examples of on both sides of how large organizations start to actually account for some of this stuff. I know on the cost side of things, it's really common when you build this kind of thing. It's really common to start using way more resources, more cloud resources than you realize. And so at some point, you usually need to give your teams visibility into that, right? And so the first step you usually start with there is actually trying to build some kind of traceability so that, and having like a leaderboard. Okay, who spent the most money this week, right? And taking steps like that can actually can actually improve things a lot. And if you get to the scale where you need to do it, you can start building effectively internal accounting systems and stuff like that to accommodate that. I haven't heard as much on sort of the revenue side of things. But yeah, I'm sure there's similar stories. If you look, if you're interested, I can probably dig some case studies up that might involve some of that stuff. So grab me afterwards.
Hey, thanks. It's right here on the left, on your left. It's right here.
Oh,
waving.
sorry.
Yep. So yeah, thanks for the great talk. One interesting inspiration I got from you was letting customer, the end user, having the access for the canary version of the product. I feel like that's kind of interesting because that feels to me like we are dogfooding our product on our end user, right? So how do you think that process will conflict with your business decision in general,
So that's,
especially for like the feature heavy companies?
Yeah, so that's a great question, and it's one of the reasons that it's so important to build your teams with that sort of that cross-functional spectrum of talents, and then that needs to include the business side of things as well. Because what was it? I was at a company once where they thought they were doing microservices. They had multiple teams, but sort of it was more sort of the separate dev teams picture, right? And there wasn't a whole lot of trust there, right? They've been trying to refactor their monolith, I think, for 2 years, and they tried to do a big cutover at one point. They were an e-commerce company, and they had a big scary experience. Their conversion dropped, and so they didn't like that, and they got gun shy, and they pretty much spent a number of years spending a lot of effort and being almost stagnant. And I think one of the things you can do when you sort of get the entire business aligned is you don't have to think about new features as scary and negative, right? You can canary testing doesn't necessarily mean bugs, right? Canary testing can actually canary testing can get domain specific as well, right? You can make it be a positive thing to have your users try out new versions of the product because they get new features earlier, right? You can incentivize it, right? You can actually give them credits to try new versions, right? So there's a whole lot of steps you can take to make that be a much more positive thing as opposed to a negative thing. Because in the end, when you do that, right, you're ultimately trying to help whoever the end user is, and so they will appreciate that if you make that clear.
Great. Any last questions? Cool. Okay. So if you decided you needed to have more questions, I suspect Rafe will be able to answer them individually, one-on-one. But also remember the panel discussion that we're having at I want to say 4:10 to 5 o'clock period, something like that. All of the speakers will be there to answer your questions in a group. See you later.